Hello student. Now see the graphs for the term 1 by j omega n. That means if there is any pole in the origin, then how will be the graph? Okay. So see the magnitude of the term 1 by j omega to the power n. That means to the power n means there is, if n equal to 1, there is one number of pole lie at origin. If n equal to 2, there is two number of pole lie in the origin. Okay, so see the magnitude of the term 1 by j omega to the power n in decibel is given by 20 log 10 mod of 1 by j omega to the power n, and this is equal to minus 20 into n log 10 base omega, and the phase angle is given by angle 1 by j omega to the power n, and this equal to minus 90 into n degree. So in from this equation the graphs, for this equation the graphs are shown like this. Okay, so see the graphs for the magnitude versus log 10 base omega is a straight line having a slope of minus 20 into n dB per decade. Okay, and as the term 1 by j omega to the power n has only imaginary term in the denominator, the phase angle is minus 90 into n degree. Okay, so see the graph. So for magnitude plot, if there is one pole at origin, that is if n equal to 1, then our graph is minus 20 dB per decade. Okay, if there is two pole, then our graph is minus 40 dB per decade. Okay, and if n equal to 3, then that means the three number of pole lie in the origin, then our graph will be minus 60 dB per decade. Okay, so in this way plot the graph, plot the magnitude and phase angle graph. Okay, now see the graphs for the term 1 plus j omega t. This graph we have already discussed in previous lecture. So see here the magnitude in decibel for the term 1 plus j omega t. 1 plus j omega t, that means there is normal 0 is given by 20 log 10 mod of 1 plus j omega t. This is equal to 20 log 10 root under 1 plus omega square t square. Okay, so consider the following two cases. First case is if omega t very less than 1, that is very low frequency, omega t is negligible as compared to 1. That's why 20 log 10 mod of 1 plus j omega t, this is equivalent to 20 log 10 base 1, that is this is equal to 0 dB. And for second case, in that case if omega t is very greater than 1, that is very high frequency, then 1 is negligible as compared to omega t. That's why in that case our magnitude 20 log 10 mod of 1 plus j omega t, this is equivalent to 20 log 10 root under omega square t square, this is equal to 20 log 10 omega t. And this is equal to, we can write this 20 log 10 omega t, we can write this 20 log 10 omega minus 20 log 10 1 by t. So from these two equation, that means from this and this equation, the graph for case 1, lies on 0 dB axis, whereas for case 2 the graph has a slope of 20 dB per decade. Okay, so these two graphs intercept on 0 dB axis at a point determined by equating the right hand side of equation 7.56. So if we equating right hand side of equation 7.56 equal to 0, then we find see this one 0 equal to 20 log 10 omega minus 20 log 10 1 by t. Okay, so from this equation we can write omega equal to 1 by t. Okay, so hence the two graph intersect on 0 dB axis at omega equal to 1 by t. That means this true graph, that means for case 1 graph is 0 dB and for case 2 graph have 20 dB slope, this one. So this is one graph and this is one graph. So these two graph intersect at omega equal to 1 by t. Okay, clear? So see, hence the two graph intersect on 0 dB axis at omega equal to 1 by t. Okay, so the graph for case 1 and 2 are shown in the figure A, figure 7.18.3a. Okay, now see the phase plot. The phase angle for the term 1 plus j omega t is given by phi equal to, this is phi equal to tan inverse omega t by 1. Okay, now see, at very low frequencies, that means when omega t is very less than 1, that means omega t is very small, in that case phi equal to 0 degree. Okay, and in second case, if omega equal to 1 by t, that case phi equal to 45 degree. Okay, so see the graph at at very low frequency phi equal to 0 degree, and at omega equal to 1 by t phi equal to 45 degree, and very high frequency when omega t is very large, then that case phi equal to 90 degree. Okay, so the graph for phase angle is this. At omega equal to when our frequency is low, then phi equal to 0 degree. When omega equal to 1 by t, then phi equal to 45 degree, and when omega equal to we have very high frequency, then phi equal to 90 degree. Okay, so this is our phase angle plot of our Bode plot. Okay, so these are the phase and magnitude plot of normal 0, that means 1 plus j omega t or 1 plus s. Okay, st, 1 plus st.